Hey guys, it's me, Travis. Here I am. We're going to do one quick question. We're just going to solve for this one here. It's a little different than most, but it's not too extreme. So they want me to find dy dx given that y equals cosine x, and then I have that cosine x, then I have raised to the power sine x. So it's an exponential function, guys. Well, kind of, but it is. You have an exponent. So the first thing we're going to have to do, we're going to have to bring that sine x down. And you do that by putting an ln. So a little bit of algebra, I guess. So let's go ahead and start y equals cosine x to the power sine x. And then I'm going to put ln. Whatever you do to one, you do to the other. So ln. And it's ln of all that. And then we can use our power rules for logarithms. So now I can rewrite this as ln of y equals, and we can bring that sine x to the front here, sine x times ln of cosine x. So I think we're good now. So now we're going to take a derivative and we're going to use the product rule. So the derivative of ln y, we're doing it implicitly because we're doing it with respect to x here, right? So derivative of ln y is going to be 1 over y, but that's not an x, so you got to write dy dx next to it, equals, and then we're just going to do product rule here, guys. First times derivative of the second, if that helps, like that. So derivative of the second here is an ln, so 1 over cosine x times the derivative of, you got to do chain rule, times the derivative of cosine x is a negative sine x. So let's see, first times derivative of the second, 1 over cosine x times negative sine x, plus second ln of cosine x, that's the second there, quote unquote, times derivative of the first, and derivative of sine x is just cosine x. All right, we're almost there. So let's see, 1 over y dy dx. That's what we're going to try to find right now in a little bit. So let's see, I have negative sine x times sine x. That's going to be a negative sine squared x over cosine x. If you want, you can turn sine x over cosine x into tan, but you still got an extra sine x, guys, so just remember that. Plus, and I'm going to put that cosine x in the front here, cosine x ln of cosine x. If you wanted to, you could put cosine x in here, so cosine x to the cosine x, but there's no real need for that. And then we're going to go ahead and multiply it by y, so put like a giant parenthesis around all this here. And we're just going to go times y, whatever you do to one, you do to the other, right? Times y. So that cancels that. So now you have dy dx. That's what we wanted. We wanted to isolate dy dx. Dy dx equals y, giant parenthesis, negative sine squared x over cosine x, plus cosine x ln of cosine x. And then last but not least, that y there, remember that you started out, it says y equals cosine to the power sine x. And of course, you have domain restrictions, but we'll talk about that in a little bit. Dy dx equals, and you're going to write cosine x to the power sine x times, and then negative sine squared x over cosine x plus cosine x ln of cosine x, close. And of course, guys, remember you have domain restrictions because ln cannot be negative. So you have domain restrictions, but there it is. That's how you find the derivative of cosine x raised to the power sine x. Hopefully, if this video made sense, give it a thumbs up, or if you got some entertainment out of it. If you find any errors, let me know. And yeah, I think we're good. I didn't catch any, but if you catch any errors, please let me know and I'll correct it. All right, talk to you guys later. Bye.